Hi everyone, I am Sandhya, Department of Mathematics. Today we are going to discuss about the transform and differential equation elementary properties. If z of f of n equal to f of z, then z inverse of capital F of z is equal to small f of n. So in this z transform of f of n equal to capital F of z, here we taking the inverse. So z inverse of f of z is come from f of n. So next we are going to see about some basic formulas. So z of a power n equal to z divided by z minus a. So taking z inverse, so a n value is equal to z inverse of z divided by z minus a. So z of minus a power n value is, so it is positive in the z divided by z minus a. It is a negative a n, so z divided by z plus a. Okay, so next we are going to see about the third formula, z of n equal to z divided by z minus 1 the whole square. So similarly here also we taking z inverse. Okay, so wait. So here also z inverse of z divided by z minus 1 the whole square equal to n. So what is the n formula in z inverse divided by z inverse of z divided by z minus 1 the whole square is equal to n. So see the remaining one, z of n a n minus 1 is equal to z divided by z minus a the whole square. So here also z inverse of z divided by z minus a the whole square is equal to n into a power n minus 1. Okay, so similarly we are going to see about the some important properties. So in this say find the z inverse of 1 or z of 1. Prove that z of 1 equal to z divided by z minus 1. Here the mod z greater than 1. We know the formula z of f of n equal to summation n varies from 0 to infinity f of n z power minus n. Here what is our f of n? So here the f of n value is 1. Okay, here so yeah 1. So here z of, okay, here the f of n values we replace 1. Okay, in the interval 0 to infinity. So in this z power minus n come from the denominator. So 1 divided by z power n equal to summation n varies from 0 to infinity 1 divided by z the whole power n. Next we have to substitute the n values, n equal to 0 and n equal to 1, n equal to 2 up to infinity. The value is 1 plus 1 by z plus 1 by z square. Okay, next here we using the binomial formula 1 minus 1 by z whole power minus 1. So next taking the LCM, z divided by 1 divided by z whole inverse. Okay, so here also see the same formula. Next taking the reciprocal on. Okay, so z divided by z minus 1. So this is the answer. So similarly we have to prove the find z of minus 1 power n. So z of f of n is equal to summation n varies from 0 to infinity f of n z power minus n. Here we replace f of n is nothing but minus 1 power n. So summation n varies from 0 to infinity f of n is minus 1 power n into z power n. So next step is minus 1 divided by z the whole power n. Then we have to substitute n values 0, 1, 2, etc. Here also we using the binomial formula. The binomial formula is 1 minus x the whole inverse. Here alternative sign, so we put positive, so 1 plus x the whole inverse. So z plus 1 divided by z the whole inverse. Next cancelling the inverse, so z divided by z plus 1, z divided by z plus 1. Next we are going to see about these basic properties. In this property, first one is linear property. So you know the linear property already know in the Fourier transform. So here also we want to apply the Z inverse. Okay, so linear property Z of A into F of n plus B into G of n equal to A into capital F of Z plus B into capital G of Z. You know Z of F of n equal to capital F of Z, Z of Z of n equal to capital G of Z. Here A and B are constant. Then we have to using the Z of F of n formula, that is summation n varies from 0 to infinity A into F of n plus B into G of n into Z power minus n. Then we have to multiply Z power minus n on both sides. So the answer is A into Z power F of n plus B Z into Z of n. So this is the A into capital F of Z, B into capital N. So hence the right hand side. So taking the left hand side, then we have to prove the right hand side, that is the linear property. Then shift scaling property. If F of t is equal to F of Z, then Z of e power minus at F of Z equal to F of capital Z into e power at. Okay, next we have to substitute Z of e power minus at into F of t is nothing but F of Z at Z tends to Z of a t. Z of e power plus at F of t, Z varies from Z minus at. Okay, then we have to using the same formula Z of F of t value. So summation n varies from 0 to infinity F of nt equal to Z power minus n. Here we have to prove this Z of e power minus at F of t. So summation in this F of nt, we replace e power minus a nt F of n into Z power minus n. So here also we interchanging the value. So F of nt is at e power minus at into minus n. So this is the F of Z of e power at. Okay, so next we are going to change scale property. Next property is change scale property. In the scale change property is if of Z of F of n equal to capital F of Z. Here Z of a n F of n equal to F of Z by A. So in this previous one we are using the transformers F of S by A. So here also we use F of Z by A. So Z of F of n equal to summation n varies from 0 to infinity F of n Z power minus a n. So here we replace F of n is nothing but the a n F of n. So a n is a constant, take it outside. So here F of n equal to Z divided by a whole power minus n. So here we replacing n equal to 0, 1, 2 etc. So F of Z by a. So this is the F of Z, Z tends to Z by a. So this is the property for the Z transform. So similarly we are going to see the second shifting theorem and differentiation of Z domain. Okay, so these are the properties for the Z transform. Thank you.